Perfection. Okay, so we have been talking motion, forces, okay, right? Yeah?
Yep.
Now I want everybody to chime in. I don't want to hear it quiet in here today. I want like everybody to go ahead and just give me the answer. It's totally fun this time. I don't know what that was. You feeling okay? Anyway, so motion and forces. So if I have an object and it is traveling at a constant velocity, what can I say about the forces that are acting on that object?
Balance.
They're balanced. So my net force is?
Zero.
Zero, yeah, because there's nothing that's going to affect its velocity. Okay, so it keeps moving because of its inertia. Remember, matter's kind of lazy. I'm good. I'm just going to keep moving. Nothing's forcing me to turn, slow down, speed up. I'm just going to keep doing what I'm doing, right?
Mm-hmm.
But if I want to speed the object up, slow it down, make it turn, what do I need to do?
Make an unbalanced force.
What's that?
Use an unbalanced force.
Okay, so unbalanced force. So I would need to apply a force. Okay, and that means that they wouldn't balance. Okay, so take for example if I take a ball into space. Okay, and I just let the ball go. Give it a little push. What's it going to do? Yeah, so it keeps going. So what's constant? Speed and direction. So constant velocity. And if I were to draw a free body diagram for that, what would it look like?
Just the ball.
Just an air going out.
What's that?
Either just that ball or
What forces them? In space? Yeah, what forces would we have in space?
Nothing.
Yeah, in the middle of space, you're not going to have anything, right? So it would be no force, but then our net force would then be what?
Zero.
And that means the forces are
Balance.
balanced, and our velocity will,
Constant.
it will be constant. It will not change. So if I take an object and I move it in space, it's just going to keep going, right? Thank you. So this is a simulation of space-time. So how many of you have heard the term space, the fabric of space-time?
Me.
The fabric of space-time, it's warping. You guys, sci-fi, science fiction? Okay. Well, we talk about space, we talk about time, but it actually makes very much sense to bring them together. Yes, this is the actual fabric of space-time. You like that? It's a fabric. See what I did? Well, he did it, but whatever. So, if I say, hey, you know what? I'm going to meet you today at 3:15. What's the first thing in your head? What's the first question that comes up? Why? Well, besides why. Where? Right? Because I can tell you a time, but we need a place. Pretty much any interaction you have can be represented by, three coordinates because of a three-dimensional system, so X, Y, Z, okay, anywhere. But we also have a time that we're existing in that point. And any interaction you have with somebody is going to be at a certain point at a certain time. So we can very much mix those two concepts. Okay, so we say space-time. Now, space-time can get a little warped. Okay, so answer me this. An object in space, give me an example of an object in space that does not just travel in a straight line.
The Earth.
Yeah, the Earth. We're here, right? Yeah, the Earth. Okay? Sure. Yeah. So the Earth is probably the most well-known one because we live on it. And it doesn't travel in a straight line. How does it travel?
In orbit. Orbit.
Doing this, right? The orbit, the damn. So it travels in an orbit. It's turning constantly. Well, what causes something to turn? Yeah, force. Must be an unbalanced force. And where is that unbalanced force coming from? Yeah, and what do we call that force?
Gravity.
Gravity. Okay, so gravity is acting on, you're not going to want to actually sit there, please. Just in case, and you'll see why in just a second. But we have that force of gravity acting on Earth. Now, why does Earth keep moving? what is that cause? It's inertia, yeah. Again, an object's resistance to a change in its motion. The Earth was going, okay, so it has velocity, but that velocity is constantly being changed because of the sun's gravity. So if we put, let's see, let's do, okay, I'll use, I will use, there it is, so if I take something with a lot of mass, okay, because we know gravity is affected by what? Mass, that's one of the big things that causes gravity. If something has mass, it has gravity. I'm warping space-time. Now it's not just a nice, neat little even system, right? So we saw this marble roll right off the end and continue on into space, right?
Yes.
But now, if I roll the marble, one more time.
That's so satisfying.
We now have an orbit.
Whoa. I love that.
So our velocity is constantly changing due to that inward force of gravity. All right, so everything has gravity. Thank you. Okay, we have gravity. We have mass, therefore we have gravity. So technically, we could say that we're all attracted to each other. It's going to make the next school dance interesting. Okay, so 2 marbles, really small mass, right? So what, again, 2 things that affect gravity?
Mass and distance.
Mass and distance. So really small masses. And if I place them in space, well, that's exciting. Not really. I'm being sarcastic. But they have gravity. We know that because they have mass.
Yes.
But why aren't they?
Like,
What's going on?
Gravity?
Yeah.
They're really small, so it's not that much force, which makes them not attractive.
Yeah. So there's not much force going on, and if you don't have a whole lot of mass, which is our numerator, okay, and then you have a lot of distance, what's that do to your whole fraction?
Force of gravity is
Yeah, so if we have our formula, so force of gravity 2 over distance squared. If we have a really small mass, which is our numerator, and a really large distance, what's that going to do to your force of gravity fraction? Yeah, your fraction is going to get small because that's like having like 1 over 100, right? That's a really small number.
Yeah.
Okay, so how could I maybe get these to be more attractive? I could increase the mass, but can I do that to an object? I could decrease the distance. So if I do that, if I take these and I put them closer together,
Yay.
they want to come together. Okay? Now these little objects are actually warping space-time, but just it's so small that you won't really notice it in the fabric. And this is not a perfect model because we have what here that we don't have in space? What other force?
Gravity.
Besides that? No. What's another force acting against motion? Friction. So we have friction from the fabric, but we wouldn't have that in space. So again, not a perfect model, but it's close. All right, now what if I take 2 larger objects? So I have these, okay? If I place them further apart,
They'll follow each other. Happy ending.
yeah, they live happily ever after. Okay, but yeah, notice what happened. Okay. Oh, hey there, hey, oh, there we are. It's like they're passing each other and their eyes lock. Okay.
Yeah.
Oh no. Okay. So yeah, so that's we could put them much further apart because we have much more mass, so our force of gravity is going to be greater, and so the distance doesn't affect it as much as the smaller mass objects. Okay. All right. So let's take a look at if we had a really large object.
That looks fun.
Okay? So what would this be like?
The sun.
This could be like our sun. Okay, compared to like these little things here. And we're really close in space-time. Yeah. Okay, so let's see. I'm going to throw a few marbles in here.
That's so satisfying.
All the planets are gone.
And we're going to get some pretty good orbits out of this. There we go. Not bad.
Do it.
First
Don't die, don't do it.
Alrighty. Now, again, not a perfect model because in space, is that necessarily going to happen? No, because you have your inertia from your planet, the planet moving, and you have the force of gravity pulling it and turning it inwards, but this is actually sloping inwards, so eventually the balls are going to stop because of friction, and in space that wouldn't happen. That's why we're not hurtling into the sun right now, okay? So another common thing that people wonder is how is it that all the planets are going in the same direction, okay? So all the planets, they rotate around, or they revolve around the sun in the same direction, right?
Yeah.
That's weird. I mean, it's like, well, wow, did somebody put them all out there and kind of give them a little push in the same direction in the beginning? It seems like just too coincidental, right? But if we watch, if I throw, let me see if these will work better first, and we'll try with more marbles. But if I just throw these out there and kind of let them go, wow, that was, the odds of that happening were, no, that didn't work well at all. Hold on. Bear with me. Let me try the marbles. Okay, so let's just kind of... Okay, so we got some chaos. But over time, it still didn't work.
How I met
You know what's funny is when I tried this out this morning, it worked just fine. I was like, oh great, this is gonna be awesome. And of course, when it actually, I go to perform. So now we have our two objects, and finally what's left over is moving in the same direction around. Okay, so if you have chaos, eventually you're gonna have some kind of order that comes out of it, from all the collisions happening, and what ends up being left over is gonna be your planets moving in the same direction. No? Yeah, they messed up. Okay. Well, we have one planet going in one direction, so I guess that works.
Wait, you got here?
Thank you. All right. So yeah, eventually, had this worked as well as it did in the morning, you would see that after all those were, hey guys, can you shut the door for me? So after all those had done what they were going to do and collided, eventually you'd end up with a few planetary bodies that were going in the same direction. And then if I'm really good, I might be able to get a good visual of the moon and the Earth, which have a larger montage. So here we go. And pay attention to what happens to both of the planetary, or the celestial bodies, I guess, the moon and the Earth, as they go on. Whoops. Hold on. There we go. Nope, that's not right either. There we go.
Nope. It wasn't working. We got the
We got close. We got close. Let's try one more time.
Yeah.
Almost.
Almost.
But what ends up happening to their orbits?
It's gone.
The Earth orbits around the sun, the moon orbits around the Earth. That sounds
But eventually, which one got killed first by the sun? Okay. Now keep in mind, there are other factors that go along with this in space, but it gives you a pretty good idea of how just gravity is affecting these large bodies in space.
Is
that what it's supposed to do?
There we go.
nice.
World record.
But then watch what happens.
And nothing happened.
Oh, give it time. It'll happen. There it goes.
And then the world ends.
Cool, right?
Bye, Moon.
That was the best one all
But
day.
then we die soon.
Keep going. Let us die. Do it. Don't do it.
Do it. Don't give us a slow death.
Yeah.
They just lied to destroy the world.
All right.
Destroy the destroyer of the world.
So we're going to now see what happens if we could have the ability to just turn gravity off.
Bye.
Oh, we're going to. So, here's my son, okay? Now I want you guys to watch this moving, okay? And I'm gonna pull the sun, okay? So basically we're gonna be turning off gravity. So watch this and how it moves before and after, okay? All right, there we go. Okay, so what did it do?
It stayed in its same state of motion.
Let's try it one more time. Okay, here we go. So what did it do?
It went to continue going in a straight line at constant speed.
No, it having gravity in that state of motion.
Yeah, so it ended up. So what before I took the sun out, what would the forces on this be balanced or unbalanced?
Unbalanced.
Unbalanced because of gravity. But if as soon as I take out gravity, what forces are acting on this?
Nothing.
Nothing. So at the moment gravity turned off, the velocity at that moment is now constant. Because now what force is going to change it?
Nothing.
Exactly, and that's why we saw, and I'll show you something else that also demonstrates that. There's nothing at that point that's going to change that. Now, obviously, we can't just turn off gravity. Now, if I put a marble in here, okay, and I get this going real good. Oops. Nope. Okay. There we go. So, it's because this is bouncy. Okay. So if I get this going, it's going to keep going in a circle. But if I were to open the ring, okay, I'm going to open this halfway, like so. And we're going to see that once, whoops, it just keeps going in the direction that it's heading at this moment when there's no more force acting on it. So it's just boom, straight line. Okay? Alrighty. So, questions about what we just saw? Something where you're like, yeah.